start by defining what fractions really are. Let's start with a formal definition. The formal definition says the set of all numbers that can be written in the form a over b, where b is not equal to 0, and a and b are both integers, are called the rational numbers. This means we need to be able to write it as a fraction without a 0 in the denominator, so the b not equal to 0 tells us that the denominator cannot be 0. And a and b are both integers. Integers are our whole numbers plus their negatives. So things like 0, 1, 2, 3, 4, 5, etc., but also -1, -2, -3, -4, etc. Examples of rational numbers would include 2/3, 4, because it could be written as 4 over 1. We could have something like 2.5 over 3, because it can also be written as 5 over 6, which satisfies our definition. We could have things like -0.25, because that's -1/4. In particular, any decimal that terminates that eventually ends is going to be included in our rational numbers. 0 can be written as 0 over 1. And finally, 0.22222 forever is written as 2/9. Decimals that repeat indefinitely, like this one, where it repeats the 2 forever, can also be always written as fractions. So any decimals that end or infinitely repeat. Some non-examples: pi over 3. Pi is not an integer, and we cannot rewrite this to be an integer form, so this would not be a rational number. In addition, the square root of 2 has a decimal representation that doesn't end and never repeats. So this would not be a rational number. This would instead be known as an irrational number. Now that we have the idea of a rational number, let's look at the word fraction. The word fraction can actually be used in many ways. Sometimes it means a small part of something. Sometimes it means a rational number. Other times, it might be a number written using fractional notation. For our purposes, we will say that a fraction is a number of the form a over b, where b is not equal to 0. This is close to our definition of a rational number, but not quite. You'll notice I'm not restricting the values of a and b to be just integers. I'm claiming they can be any number. And this is a precise definition, and precision matters when we teach. You're already thinking like a math teacher by starting with meaning instead of rules.